just recording my audio as well. So thanks for waiting. And as I said, this is session 3, video number 3 about multicast. So we'll be looking at how to configure multicasts, what we need to monitor with multicasts and why, and how we set multicast thresholds. Now, they're important because every system is going to be different. And we have if you like, an ethos at Bridgetech that it's not necessarily about the, let me share the screen that you'll be seeing. Okay. So you should now all see my web browser. Yes, so it's not about necessarily what is in spec and what is out of spec. There are a lot of specifications, MPEG over IP, ETR 290, all sorts of specifications. And although they are specifications, they're not necessarily indicative of how a live system works. We all know systems where something is slightly out of spec, but it works fine. And if that is slightly out of spec and it generates an alarm, but it's still working, then very often people in NOCs and MCRs, they ignore these alarms. So we try to talk about a green monitoring system in the sense that everything is green and it's working, so that when you see an orange or a yellow or, heaven forbid, a red alarm, you know that there's something genuinely wrong. Anyway, we'll talk a bit more about that later. But for now, I want to talk about multicasts. So we're going to be looking at 2 probes. I'm looking at my main training probe, the one that I've deleted most of the multicasts from, just so that we can see how we add multicasts. And I'll be looking at a pre-configured probe. This is the probe on the demo system, which has already got multiple multicasts already in. And if we look at the main screen, we can see that we have in fact joined 35 multicasts here. So we're looking at 35 multicasts here. And on the training probe, we've just joined a single multicast. So we'll be concentrating on 2 tabs. We'll be concentrating on the multicast tab, which basically gives you a table view of the multicast that you're monitoring. In other words, it gives you a lot of numbers and data, and these are really good for establishing where multicasts are actually at, if you see what I mean. Give you the numbers that are important to know. Things like inter-arrival time, which of course is a measurement of jitter. Media loss rate, MLR, which is a measurement of dropped transport stream packets. We'll be talking mainly about UDP multicasts, but the probe does support RTP, and we'll look at those as well. And then we'll look at the media window tab, which doesn't show you much here, so I'll skip quickly back to the demo system probe, and this gives you a more graphical view, an overview of the situation over the past 4 days. If I click the 4-day button, and this will give me a graphical view and a sense of how things have been behaving on these multicasts over the past 4 days, or indeed the last 20 minutes. So we'll be coming back to this and looking at this in a lot more detail in a minute. So for now, we'll go back to the probe and we'll go back to multicasts. Now I'm going to take you through these tabs, but we're going to start with the streams tab. As I said, the parameters tab, what we're looking at now, is an overview, and it has several. In fact, I'm going to make this screen slightly bigger. We'll lose some of the data off to the right hand side of the screen, but that doesn't really matter at the moment. We will look at these drop downs. We've got several drop downs, and we will always start at the user defined parameters. But we can look at RTP. If we were looking at an RTP streams, we could see the RTP streams. Now these would show me columns of data that were specific for RTP streams. things like out of order packets, RTP duplicate packets, minimum hole size, maximum hole size. There's a whole load of RTP and FEC parameters there that would be very useful if you are looking at these types of streams. Ethernet parameters, just the Ethernet streams. It's like a source address, 7 transport stream packets per UDP, IP frame, Ethernet frame rather. And things like transport stream parameters. So number of CC errors, number of PIDs that make up this transport stream. So you can see, you can show these data in exactly the way that you want to do. And as I said, it starts off in the user-defined data area, user-defined view, and this is customizable by the user, and it's simply by pressing the fields button. And then we did touch upon this last week when we looked through the GUI, but you can add any of these parameters to the user-defined view. So this would give you basically a way of customizing the view to only show you the parameters that you wanted to see. Now if I apply that and we go back to the parameter screen, then somewhere along here we're going to have out of order packets. There we are, RTP drops, there it is, number of holes. So they're there. Better take those out now. Number of holes, well, I'm going to take out RTP drops as well. Okay, so the user-defined parameters give the user the possibility of showing this display exactly as they want it. And of course they have the number of pages. So on a VB 120 and 220, on a VB 220 anyway, you have 20 pages, and you can assign multicasts to a page. Just looking quickly at the other probe, we have 5 pages set up, and we've given them names, which you can also do. I'll show you how to do that later. But we can add pages, and we can add multicasts. So we could add all the movies to page 3, for example. We could add sports to page 4. We can call these pages any name we want, and we can name up to 20 of them. Again, another mechanism by which the user customizes the probe to show him the data that he wants. So let's start with streams, as I said. So we have one stream here, and if we look over, we've got a name, we've got the edit button, and I, for one, I don't know about you guys, but I, for one, want this edit link to be at the left of all streams, because this is the only stream that I can find that it's actually on the left. All of the other streams, it's at the right, and that means you have to scroll to the right just to be able to edit the particular row that you're looking at. Of course, that's not true. You only need to highlight and then edit. But it's really convenient having the edit link right at the left. You can see it's joined because there's a tick in the join column. There's a tick in the thumbnail column, so we've asked it to extract thumbnails. And then we've got various parameters here. So multicast, destination address and its port, session IDs, and some various other things. And then we've got thresholds. Thresholds define, remember, thresholds define where the alarms start and end, if you like. They define where the limits of the alarms are, when basically how sensitive the probe is. And we'll be looking at Ethernet thresholds today because we're looking at multicasts. Now, of course, inside every multicast is either an SPTS MPEG stream or an MPTS MPEG stream. So there's still an MPEG stream in there, and we'll cover that next week when we look at ETR290 monitoring. So although we're just looking today at Ethernet monitoring, so things like jitter, drop packets, bandwidth, there's also that transport stream which can also be analysed and monitored if you like. But we'll be looking at that next week, so we won't be covering that this week. So let's just add a new multicast. Now the thing to remember, the thing to look at is this IP address the destination multicast address. 239.255.04. Sorry, I'm just trying to organise. I'm waiting to see if there's anyone else in the lobby waiting to come in, and there isn't. So we're looking at a multicast 239.255.0.4, and when we add a new multicast, so we can just add a new one by clicking here, you'll see that the first thing it does is the second thing it does, in fact, is add a multicast address that it increments up from the previous one. So it will add 5. It will keep the same port. It won't change the port. So that's not so good if you're adding lots of multicasts that have the same multicast address, destination address, but the port increments, because I've seen that before. But when all said and done, most people increment the IP address. And it gives it a default name, and that default name is the multicast address preceded by NC. And of course I would give that another name. I've no idea what is on this multicast. So let's just pretend it's CNN. It isn't, but let's just pretend it is. We're going to leave it at the default thresholds, but we can select the Ethernet thresholds. And because we're not talking about any other thresholds at the moment, we're going to leave it at Ethernet thresholds. So we'll leave it at default. Now we need to join the stream. The default position for streams is not joined. So we can add we could add 20 Ethernet addresses, 20 multicast addresses, and none of them will be joined by default. We have to go and join them. Notice that extract thumbnails is default on. And we need to say where it's going to be joined. Remember that all of these probes now, all hardware 4 probes, come with the ability to option the second data input, the SFP. So you need to tell the probe which interface to go out and join the multicast on. And then you need to tell it what page. So as I said, we've got 20 pages. We've named, we haven't named any of them actually at the moment, but we can add this. So we could add this to page 2 if we wanted to. If you don't select a page, it will automatically fill up page 1 and then move to page 2, and it will do that. Source-specific multicasting. Well, if you are doing source-specific multicasting for things like failovers, if you're doing things like you're failing over and the multicast stays the same, but the source address changes, then you'll need to implement SSM here. You give it an address and a name, and it's the name which is used for the source address username. So for any source address match, the monitoring page's source address will display the username. So again, it's another means of making this a little bit more comprehensible. ETR monitoring, remember we've got an MPEG transport stream inside here, but the default position is off. So we don't monitor ETR 290 by default. We have to turn that on. So I will turn it on. And we'll select an engine. This probe has only got 4. But remember, a VB120 or a VB220 can option up to 50 ETR engines. And a VB330 can option up to 400 engines. So you've got a really long pull down on a VB330 if it's fully optioned. And you want to get to, if you want to get to ETR engine number 400, you've got a lot of scrolling to do. I'm not going to talk about thresholds at the moment because we come to those in later weeks. But for now, we've enabled ETR and we've selected engine number 1. T2MI, we're not going to get into T2MI because this is not a T2MI stream. Redundancy, well, we need to turn FEC on for a start. If we're doing forward error correction, we need to turn that on. And as you see, it's code of practice 3. So we don't have FEC, but if we did, we'd need to turn it on. The probe won't sense FEC. Layer 2 tunneling protocol, we'll do a session on that. Well, we won't do a session solely on L2TP, but we will include that in a hidden features session in a few weeks' time. So we apply the changes and we close it. So now we've got CNN International, which it may or may not be, and we've basically added another multicast. What I'm going to do now is I'm going to come down to this N box, N equals 10. So I could add 10 multicasts just by clicking the add N. And now, when you're looking at multicasts in an IPTV system, particularly in a head end, then multicasts very, very frequently are sequential. So it's a really nice tool to be able to add 20 multicasts. So we could add, I'm just going to add 5, but I can add any number, well, any sensible number, and then add N. And you notice that the multicast addresses have incremented from 6 to 10. None of them are joined. If you look at the join column, none of them are joined. But because there are a number of things that we can do, we can click, shift and click. And now we can edit multiple streams at the same time. Obviously there are certain things we can't edit. So if we edit those, we can't edit the name because each one's got a separate name. And we can't edit the multicast address because each one has got a different multicast address. But we can change the thresholds, we can join the streams, we can add the join interface, and we can add them all to page 2, for example, and apply changes. We could distribute the ETR engines by clicking on that button. And that would distribute them. So it would distribute, we've only got 4 engines on here, so it would go 1, 2, 3, 4, 1, 2, 3, 4, and so on. If I had 10 engines, it would go 1, 2, 3, 4, 5, 6, and so on. And we could add certain multicasts. So we've got these 6 multicasts that we've, only 5. We've had these 5 multicasts, and we could actually say, well, just join them all from page 4. And then we could join, unjoin, fill pages, unjoin all, and then the fields we've seen, we can show which fields we want to see. Okay. So they're all joined now. Now when we go, because we've got different pages, and if I scroll down here, you'll see that page 1, and then 2, 2, 2, 2, 2. All looking at ETR engine number 1. So, in fact, let's edit that and put that into engine number 1 as well. In fact, no, we'll put that on engine number 2 so that you can see how that works. So we've added now 7 streams. Let's go back to the parameters and see how these appear. Okay, so we're looking at page 1 and we can see 2 streams. Now there are 3 views because the bottom one is the accumulated. So basically TV Norge and CNN International are added together and they are given an accumulated view at the bottom. If we select page, I can't remember which page I chose now. Was it 3? No, must have been page 2. Yeah, and there's page 2. So this shows you how these pages work and how it's really easy to keep these separate. Now, interestingly, they've all got bandwidth on them. So if we look at the current bit rate, all of these have got these multicasts are correct multicasts, and that's because that's how our system, the demo system, is set up. So now we've added a single multicast, and then we added 5 multicasts. So it's very easy. You can, of course, by using the data page, you can. If I show you the data page, you can export stream list without join information. And you can export the stream list with join information. So this gives you 2 different files. And you can upload these to any file, any any probe. And if you upload the one without join information, then none of the multicasts will be joined. They'll all be there in the Streams tab, but none of them will be joined. The other one, of course, the join information, yes, they will all be joined. So again, this is a very useful way of... let me just look at this quickly. So this is the join information. There's a single multicast there. And there's another multicast there. And we'll find somewhere join probably equals true. I can find it. I can't. Join, yeah, join equals true. So this would cause that tick to come into the box. Now remember, this can be edited offline. You can edit these files offline, these XML files, and you can re-upload them. But if you remember from last week, you have to delete the CRC, the cyclic redundancy check, because if you make any changes to this, then the CRC is no longer valid. So just delete it. You can't recalculate it, just delete it. Anyway, that's enough diversion for that. So let's go back. I'm going to go back to the main probe now and look at some of these. Let's go to page 1. Now, not a lot of these have actually got, I'm not sure why they don't have, now let's go. Yeah, I'm going to go to the main probe because they've been running for, if you look at the signal column, it says 15 days, 43 days, 43 days, 15 days. So these have been into the probe for a long time. So these, when we look at the number of CC errors, so when I look at Discovery World, now let's look at this one. Let's look at Discovery Science. Discovery Science has been active in the probe for 43 days, and in that time it's had 213,000 CC errors. Interestingly, Hyperdeck, it's not actually a service in the way that you would expect it. It's also been active for 43 days, but it's only had 0 errors. So this is a special multicast stream that we are supplying. Anyway, so that shows you how these this screen works. Now let's actually look at one of these in a bit more detail. I'd like one with a picture actually. Close that. If I click on the thumbnail, right, I'm going to have to go to the probe. If I click on the thumbnail, then it just brings up a thumbnail. Now remember from last week, those of you who listened last week, this thumbnail stays in this probe. It's a VB220 probe. It cannot be exported anywhere in the system. It doesn't go to the VBC, it doesn't go anywhere else. If you have a VBC system with thumbnails, then those thumbnails originate from the VB288. Not from a 120, not from a 220, and not from a 330. These are just in the probe, just so that you can see them. So let's click on the I button. Now the I button will give us some information. In fact, actually, no, let me go back to the one oh no, it doesn't matter. I was going to say that this multicast, TV Norge, wasn't ETR tested because there's something I wanted to show you. So we're looking at CC errors. Now it hasn't been going long. Actually, it's been going for 2 days and we haven't had any errors. That's very well behaved. Don't often see that. So I'm going to have to go back to the other probe to show you. Now you can see the CC errors. If we click on those disclosure buttons, we can see that the PIDs, we can see the number of CC errors per PID. Now unsurprisingly, the MPEG-4 video PID has got more CC errors than all the others. And that's simply because there are more video PIDs than any other PID. So that makes sense. Now, even if remember the CC, the continuity counter is part of the MPEG transport stream. It's part of the MPEG transport stream packet. So each of the individual PIDs every PID in the MPEG TS has got a continuity counter, and that continuity counter is what we use to find CC skips or CC errors. It's a 4-bit field, so we can use this to give us a guesstimate on how many packets have been dropped. It's only 4 bits, so it's only 0 to F, so it doesn't give you an awful lot to play with. But nevertheless, it gives us a fighting chance of having a guess at how many packets were dropped. Now, you don't have to do ETR testing on a multicast in order to check CC skips, CC errors. So even if you have selected ETR testing off, then you will still see CC errors, even though the probe is actually looking at the individual PIDs inside the IP packets. So that's one thing to remember. You don't need to enable ETR testing to know how many dropped MPEG transport stream packets you've got. It's the only thing that is tested without ETR testing. So if you want things like PCR, well, perhaps not PCR, but PAT or PMT, anything like that, then you do need to switch on ETR testing. Now, there's another little graph here that people don't use very often. It's called the inter-arrival time histogram. And it's a histogram. If you don't know what a histogram is, it's fairly simple. The higher the peak, the higher the bar, if you like, the greater number of packets arrived at that time. If any of you have used histograms on your digital camera, you'll know what a histogram is. A histogram just tells you the relative brightness. On the left-hand side of the graph, it's always, well, I'm not sure which way round it is now. Whether it's the brightness, the full white at the left and black at the right, I can't remember. Anyway, it tells you the relative amount of brightness across the picture. Now, what we're seeing here is the relative number, or the distribution of packet arrival time. So we would normally expect to see a nice bell curve, something like this, with it starts off gently, it rises to a peak, and then it tails back off. So the vast majority of our packets are arriving round about, sort of between about 1 and 2 milliseconds, which is perfect for this particular IP installation, if you like. So I would see a nice bell curve like this telling me that most of my packets are arriving in that sort of narrow window. If this was spread out much more, then I would be experiencing a lot of jitter. This is an instantaneous measurement. It's not over history, although it's for as long as this window is open, then this graph updates. And it's like a cumulative graph. If I clear it by pressing on the IAT button, then that will start the counter off again, if you like. Now you've got a green line right at the left, and that shows you the arrival time of the very, very earliest packet. And the green line on the right is telling me that's actually just reset for some reason. The green line on the right tells me the latest time. Now that's obviously not. That has just reset, so let's pick one of the others and see how that looks. No, it's about the same actually. Anyway, you can look at the green line on the left, which gives you the min, max. So this is dancing all over the place. I'm not entirely sure what's going on. This is this weird multicast that we're looking at, this hyperdeck. Anyway, that gives you it's actually starting to normalize now. You can add a logarithmic scale. You can look at this logarithmically. If your numbers are really big and you need to make it logarithmic, then you can do that as well. So the inter-arrival time, quite a useful graph for troubleshooting jitter on the network. Remember, this is inter-arrival time for an individual multicast. You can do the same sort of thing for the entire interface, and you can do that here. I'm not going to talk about that today, but on the traffic tab, you can generate graphs for the entire interface, the whole data interface, not just a single multicast. So we've got summary screens. This basically tells me how many error seconds, and we looked at error seconds last week, so I'm not going to talk about those too much unless anyone has any questions. So we've got error seconds at the error seconds for the pages. So this is again another means of organizing data in a fashion that is useful to the customer. So page 1 through to page 5. Error seconds, and on this particular probe all 0 at the moment. Not sure why that's the case. Something wrong, something odd there. There should be error seconds. Let's just see over 4 days. Okay, so we have had drop packets over 4 days. So we've had quite a few drop packets. We've had no RTP errors, and we've had no signals. So actually that is perfectly normal, that display. We just haven't had any drop packets over the last 20 minutes. But we have had some over the last 8 hours. That's fine. History is, well, I don't know whether this is particularly useful or not. Again, another means of drawing a graph. You can select bit rate. You could add a couple of these parameters, and you could draw a graph. And you could draw a graph showing the number of CC errors and over time the monitored bit rate. And again, as with all these things, you can tooltip over these. This is giving us over the entire interface. This is not looking at individual multicasts now. This is looking at all of the data. So the bit rate is at 235 megabits per second total bit rate for all of our multicasts. And you can get rid of those by just clicking that, and you can just generate these graphs. I can see certainly certain times where this might be useful. Detect, we talked briefly about detect. So long as the probe is in promiscuous mode, and that's here, and the switch to which this probe is attached, so long as that switch is set up to forward multicasts to the port, then the probe will detect the multicasts. You can even select to join, so you can add various multicasts, and you can add them to the stream list. So if you've got multicasts that you're not entirely sure what's on this switch, and you want to just basically have a look, then you can add them to, and you can add them here. Session announcement protocol. I'm not going to be talking about that now. We will talk about it briefly in subsequent weeks. But if you're using SAP session announcement protocol, then you'll know what this is. If you don't, then you will probably be using it one day. Join is another mechanism for joining multicasts. We've seen the way that when we add a multicast, we have to click in the box or highlight the particular multicast and then join at the bottom. This way gives us the ability to find another multicast and join. So I could join this to the training, page 5. This is, again, page-based. Oops, wrong way. So this will now add that multicast, RMC Découverte HD. So that's now added it, and it's added it to page 5. If we skip back very quickly and look at page 5, it's not there. Why isn't it there? It should be there. Oh, I didn't. Stupid. I didn't apply the changes. I'm always doing that. Don't know why. I keep telling people you must apply the changes. And there it is at the top. And you can unjoin in exactly the same way, of course. So I can move that back into the list and apply changes. So I could unjoin multicast here as well. Streams, well, we've seen the streams. That gives us a list of all the streams. Now remember that we can use these column tops to sort. So we can sort on the join column and click and see all of the joined multicasts at the top and all of the unjoined ones at the bottom. Click it again and it goes the other way around. Thumbnails yes, thumbnails no, and so on. Normally it's I think the default is sorted on multicast address, which makes sense. Now Ethernet thresholds, we're going to talk about thresholds now. Now we're going to come back to thresholds because I want to show you the media window, because the thresholds will make more sense when we looked at the media window. So multicasts basically gives you a data-driven, a number-driven view. Everything's about the numbers. You know, number of CC errors, the number of the amount of jitter in milliseconds. Media window gives us a different view. It gives us a graphical view, and it gives us a graphical view of not much. Now remember, it's interesting that it's actually stayed on page 5. Now as long as I stay connected to this probe GUI, it will remember the page I was last looking at. So I can go to different pages, ETR 290, and I can come back to the media window and it will still remember I was looking at page 5. However, the very first time you look at it, it always looks at page 1. Now, immediately that we're looking at this page, we've got some colour. We've got some greens, we've got some oranges, we've got some yellows, and if we look at the 4-day graph, we've got a bit more of everything. We've got some yellow going up and we've got some yellow going down. So basically these graphs are showing us 2 different parameters. And then what they're showing us, looking at this, is inter-arrival time versus media loss rate. Remember, inter-arrival time is jitter and media loss rate is dropped MPEG transport stream packets. We can change to bandwidth and the color changes to blue. And this is telling us about bandwidth, bit rate in other words. And if we have RTP streams, then this will show us the RTP. Remember, RTP, real-time protocol, has got the RTP. Oh my goodness, I've forgotten the number. The RTP field that gives us the number of packets, or the number of the packet. 16 bits now, not just 4. So we've got a much better control and visibility of what packets have lost and which packets have come out of order and all of that sort of good stuff that RTP gives you. Still can't resend them because this is a multicast stream. Can't resend them, but at least we know what's missing. So RTP, when you look at RTP, it appears as purple. So if I look at this in more detail, then we can see a purple stream. If I look at TV Norge, which is a UDP stream, and I try to look at RTP, then I get a grey display. And that grey display is telling me that this is not an RTP stream. And you can, if I just make that screen a bit bigger, you can see grey and purple. So what are we actually looking at here? We've got a line that runs right across the graph. Everything above the line is a measurement of jitter. Everything below the line is a measurement of drop packets, media loss rate. Did we have some drop packets there? No, we didn't. Sorry, page 1. So we've got lots of drop packets. You can see those little yellow excursions of the graph downwards where they're all showing us drop packets. So immediately on a view we can see drop packets. And if we look at National Geographic, we can see we've had jitter and drop packets. And we look at Disney XD, we've had jitter and drop packets. And they happen at the same time, which is nice. So maybe we've had a fault that affected both of these at the same time. Didn't affect Hyperdeck and it didn't affect TV Norge. So I'm looking at current page, but I can actually look at all of the multicasts on this screen by clicking more. And again, if we look at that, we can see that excursion here, over here, and it happened about the same time. Happened about the same time to multiple streams. Not every stream, not by any means, but it did happen to quite a few. The only thing about the all button is this is an offline view. It's an offline view and it doesn't update in real time. So if you leave it on all, you won't see any changes. So going back to current page, now you start to see updated page things, updated graphs. These little graphs here to the right of the main graph are just telling you what the probe is seeing now. And if you look at the numbers, you'll see them changing. The inter-arrival time is changing, 6.35, 6.32, 6.39. So that's live updating. And if we look at this in again, if we look at this in the large screen, we can see this jitter. We can see the jitter going up and down. But it's still green, which is nice. If we move to 90 minutes, it's all still green. And the reason it's still green is because it hasn't gone above this yellow line at 45 milliseconds. So we've got a line, a yellow line, a warning line set at 45 milliseconds. And then above that, we've got an error line set at 50 milliseconds. So anytime the graph goes above 45 milliseconds, it will turn yellow. And anytime it goes above 50 milliseconds, it will turn orange. And if we look at the bottom of the graph, you can see we have figures 1. In other words, 1 drop packet. So 1 or more drop packets will give us a warning. And 8 dropped packets will give us an error, an orange graph. Let's see if we can find any of those. Yes, look, we've got 1 there, yellow. So we've gone yellow because it's just gone to 45.4 milliseconds. And that generated a warning. Now that would generate a warning, and that will go into all sorts of things. That will generate a warning alarm. It will go to the VBC as a warning if the VBC is set up that way. And it will also generate in the reports, in the VBC reports, it will generate a warning that you can then draw into a graph and see how these things have been acting up over the past 3 or 4 weeks or 4 months or 2 years. And you can see over the past 4 days, we've had jitter that exceeded the warning threshold 3 times. This is actually really quite jittery because right here the jitter is 6.6 milliseconds and here it's 46.8. So there's a big variation across on this multicast. I wouldn't expect to see this in a production system. I would expect to see this far more level. And remember over here on the right hand side, we've got the current figure, which is again updating continuously. 621, 20, it's gone up quite high. Anyway, and you can look at these in all of these graphs. If I click on that graph for 4 days, and I wanted to know when this one was, so it tells me it's between 20 and 2100 on Sunday, actually Saturday. So if I click on that, I can click on it and I can isolate it down now. I can see, whoops, it's got, sorry, 2053 to 2054. So I can actually isolate this down to the minute by just clicking through. And this would then tell me the minute that this happened. So if I need to marry this up, I can use the pop-up window. So I can generate a little pop-up window here. I'll come back to that in a minute, and then let's look at a different one. And we can pop that one up as well. So we can use pop-ups quite usefully to show more than one. And if we now look at the pop-up window there, we can see, we can actually marry these up. So we can look at 24 hours and 24 hours, and we can see the difference between these. Very different, in fact. Same probe, different multicasts. So that pop-up window is quite useful. Okay, so these numbers, 45, 50, 1 and 8, where do they come from? Where have I, who decides that 45 is a warning and 50 is an error? Who decides? Well, basically it's the user. The user decides when an error occurs, when a warning occurs. And the user implements that choice using the thresholds. That won't surprise you, because thresholds are everywhere on Bridgetech probes, and in fact on the VBC as well. Everything, every measurement on a probe is mediated through a threshold, and the threshold decides when the alarm occurs or when the warning occurs. And every probe, doesn't matter whether it's RF, ETR290, or indeed Ethernet, all of those thresholds have default thresholds installed. So we've got a default threshold, we've also got a TV threshold, a radio threshold, and an HD TV threshold. Now those are default thresholds. They are in the probe as soon as you turn it on, and they cannot be deleted and they cannot be edited. It says edit here, and it says I can edit it, but I can change this to, let's just change that to 9, and I will apply changes and I get an error message. I cannot edit them. So he won't allow you to do it, so don't worry about can I or can't I, you just cannot. So you always make a duplicate. So let's duplicate that, and let's make a threshold. Now we'll call this training, because that's what we're doing, and we'll make some changes. So first of all, we're looking at the error levels, and the error level for inter-arrival time is defaults to 50 milliseconds, and the default for the media loss rate, drop packets, is 8, and the warnings are set to 45 and 1. So let's change that. I'm going to change that down to 30, and I'm going to change the warning down to 20. I wouldn't advise you change these media loss rate, error and warning levels from 8 and 1. Don't change those. They work pretty well spot on. Remember, the maximum number of MPEG transport stream packets that you can put into an Ethernet frame is 7. So you cannot get more than 7. So you know that if you've dropped 8 TS packets, then you have probably, it's not 100% certain, but you have more than likely dropped a whole IP packet. If you've dropped one IP packet, if you've dropped one MPEG transport stream packet, you can't have dropped an IP packet. Something has packed those TS packets into the Ethernet frame and missed one out. So something like an IP streamer, an IRD, something that actually packs MPEG TS packets into an IP packet, a multiplexer, anything like that. So if you've lost between 1 and 7 packets, then the chances are it's a device, not the network. However, if you've lost 8 or more packets, then you have to start thinking about maybe I've lost some network packets. My network has dropped and thrown away some IP packets. It happens. Now you can set a maximum bit rate if you want. So let's set that to 15 megabits per second. So if my transport stream, if my Ethernet multicast the video exceeds not the video, the entire transport stream exceeds 15 megabits per second, then that will generate an alarm. Now it's just the maximum. There's no warning, because the warning is generated automatically. What the probe does is it takes 15 as the maximum and it subtracts 10%, and it sets the warning level at 10% below. And the minimum bit rate is just set to, well, as you can see, 100 kilobits. No signal. This is when the probe determines whether it's lost the multicast completely. So you can see the default value is a second. So if no multicast packets arrive so basically if there's a gap of 1 second, then the probe will call out a no signal event. In other words, the multicast has gone away. Again, you can set that to any figure you want. You could set it to 500 if you wanted, or you could set it to 2 seconds or 10 seconds if you wanted to. And the RTP drop limit, again, leave that at 1. If you drop a single RTP packet, you do generally need to know about that. So leave that at 1. If you've got PIDs that come and go, teletext PIDs, or maybe you've got multiple audios and the audio sometimes disappears, but you don't want to generate an error, then put that PID number there. So put the PID number there and put the teletext PID. Put the teletext PID as well, and these will not be counted to your CC errors. So you can add as many as you want there. Apply changes and close. So now we've got a training threshold, but we've got 0 references. So none of my multicasts are using this threshold. So let's go back to our, let's have a look. Let's look at the first one. So no, I want to go to the media window. Right, let's look at TV Norge. TV Norge is quite well behaved. Actually, it's too well behaved. I want something that's a bit less well behaved. So, yeah, okay, let's do this. Yeah, this will work. We'll get lots of warnings and errors. So R1, I'm going to go to R1. I'm going to go to my multicast tab and I'm going to go to my streams. Now again, if I've got dozens and dozens of multicasts in here, you know, I could be ages looking for this. So this little window box, you'll find them all over the probe and the VBC. Just type in R and it immediately starts a search and it will update immediately. So edit this stream. And I'm going to change the Ethernet threshold to training. Apply changes and close. So now when I go to my multicast, we should see that R1 has got lots of errors. It's got warnings because it's gone over 20. And it's got errors because it's gone over 30. Quite a lot, in fact. Now, although this has gone retrospectively and my 4-day graph for the probe now says 4 days, these alarms won't suddenly appear in the VBC. It's only new alarms that will appear in the VBC. So although it's showing me these alarms here on the probe itself, these do not apply retrospectively on the VBC and they won't appear in any reports that you generate on the VBC. So just remember that. Now the point of all of this is, there are a number of specifications out, and we'll talk next week about ETR, or rather ETSI TR101290, ETR290. We'll talk about that in a bit more detail. There are lots of standards out there, and that's one of them. And there's MPEG over IP, which stipulates a maximum end-to-end delay of 50 milliseconds, end-to-end. So there are a number of standards out there. So we need to be aware of these standards, but the standards are not necessarily going to tell us whether our systems are working. So when we went to TV Norge and we look over 4 days, nothing, our jitter is not getting anywhere close to 45 milliseconds, let alone 50 milliseconds. It's down in the 2 milliseconds level, 1.5. It's very, very fast. So this particular multicast is particularly quick. So I would think about adding a threshold to here that may be something like a warning at 5 and an error at maybe 10 or 9 or something like that. But the point is, when I look at my Discovery Science, Oh no, that's probably a bad choice. When I look at my Discovery, when I look at this R1, I'm getting excursions over 30 milliseconds. Now the probe is telling me this is an error. But is it? That's the question you have to ask yourself. Is this actually an error? Is it causing any problems downstream? Because if the answer to that question is no, there are no problems downstream, my customers, my regional head ends or whoever I am handing off to, they are not seeing problems, then these may be technically errors because they exceed 50 milliseconds or 30 milliseconds in this case, but they're not causing problems. So in these circumstances, we would say use the default thresholds. But you need to tune your probe for a green screen. In other words, everything is green. So basically you want to tune out the thresholds. You want to tune the thresholds to give you enough headroom so that even though something may exceed 50 milliseconds, so long as it is not causing problems downstream, it doesn't cause an error. This will be more apparent when we look at ETR 290 next week, but it even works for Ethernet thresholds. You don't want to blindly assume that because it says 50 is the maximum end-to-end delay, that this is, we must have an error if anything goes above 50. No, that's not the case. You need to tune the thresholds to ensure that when you get an alarm, it's a genuine alarm. If we look at this one, we look at Discovery Science, it's constantly in error. My inter-arrival time is 204 milliseconds. That's way above 50. But if I look at an IRD, or if I look at a decoder, an IP decoder, an IP set-top box, further down the line, it's quite possible that this looks fine. I've just got a bit of a delay. The delay is constant, 204 milliseconds. It's not like it's going up and down all over the place. It's actually quite constant. So long as that's being buffered at the other end, this won't cause any problems, or it may not cause any problems. So when we look at systems, when we support engineers and me as a training engineer, when we go in and we look at the Ethernet thresholds and we see default thresholds 104, then that tends to say to me and our support engineers and our developers that users have not set thresholds properly because they've just used the default. The default are really just starting points. So my recommendation as a trainer, my recommendation to you is that you use the default thresholds. And remember, we also have a radio threshold. And the reason the radio threshold, look at the radio threshold, 150 milliseconds for an error and 130 milliseconds for a warning. Why is the number so big? Well, of course, this is radio. It's audio only. There are far fewer packets in radio. So there's going to be bigger gaps between these audio packets. So that's fine. They'll send an IP packet with 7 TS packets, and then there'll be a gap because there won't be as many audio packets, audio PIDs to pack in. So there'll be a delay. And if we look at HD TV, the default is smaller, 30 and 20, because there are going to be more packets because this is HD. So you have to balance what works against what causes problems. Am I looking at HD streams? Am I looking at standard definition streams? Am I looking at a very jittery source? Am I looking at a very stable source? So the default thresholds are always just the starting point. Use them. When you're installing a system, or you're setting a system up, or you're installing a new probe, use the default thresholds. But then come back after a day or remote in after a day, 2 days. Have a look. How much orange have you got? Because these graphs are great for this sort of thing. How much orange have you actually got? If we go to the probe we just set up earlier, of course we've only been running for an hour, so we've got very little data on some of these. Except we're getting massive drop packets, continuous drop packets on this. So there's something very, very seriously wrong with 239.255.0.10. I'd need to look into that. I won't look into it. All I'll do is delete that multicast when we've finished. So some of these, this one's even faster. Look, one. So I can't determine after an hour the condition of my network. I could have a stab at it after a day or a couple of days, and then I might refine my thresholds. I will make a duplicate threshold. I might make 2, because some of my sources may be coming in on satellite and they're coming in via an IRDs, and they may be very regular, very well behaved, coming in for an IRD, constantly providing IP packets. Or they may be coming from another source, an IP source, some other IP source from another network that's handing off to me, and they may be more jittery. So in that case, it might benefit me to have 2 different thresholds, one for my IRDs, one for my multiplexer output, which has got a higher bit rate, and more for my a more forgiving threshold for my IP source coming in on a fiber. So we've looked now at thresholds. Certainly come back after a week. You know, when you've had all the weekdays and then all the weekend. You might have program lineup changes, multicast changes. There may be all sorts of things that happen across a week. And also remember, bit of sales pitch here. Also remember that Bridge Technologies have its Amiga program, the Amiga Lite, and I think it's the Amiga Gold. The Amiga Lite is a free health check on a customer system, and the Amiga Gold is a very, very detailed look at all of the probes, all of the thresholds, all of the multicasts, and things like software revisions and all sorts of things like that. It's a complete inventory of a monitoring system, but part of that inventory is checking that the thresholds are correctly set for the system as it's working. So if you've got a customer who doesn't want to set up their own thresholds, doesn't want to do a real fine-tuning, and remember the fine-tuning is essential to get a really responsive, accurate monitoring system. It's no good just using the default thresholds forever. You must fine-tune it. And if you don't want to do it yourself, then we can do it for you. We can train you to do the Amiga program and you can sell it. You know, there's another opportunity for making money, not just sell the probe, not just sell the upgrades, the feature set, you know, the extra ETR engines, the second interface, all of those good things that can earn money, but also the Amiga program, this fine tuning. This is an opportunity to make some more money. So anyway, on that uplifting note about making money, we're going to call a halt to this particular recording, and thank you very much for your time for this hour. We've gone over an hour again. I'm sorry. I do keep saying that these are going to get shorter, but an hour just seems to be about right. The video will appear. The quiz is already there, bit.ly/quiz_session_3. That will appear on the website tomorrow. And I'll also send out emails to everyone here and also everyone who wasn't here. So everyone's going to get an email tomorrow giving you the details. And thanks again for your time. And I hope to see some of you next week.